Lecture, I'll be teaching you about the coordinate number of NaCl. As in previous lecture, I've told you about the lattice structure of the NaCl. First of all, let's have an overview on what I've told you. I've told you that in the lattice structure of the NaCl, we have a unit cell. In the unit cell, we have Na. Na are connected in the center or in the edges, while Cl are attached on the corners as well as on the faces. Remember this structure? Now you'll be able to understand that what is drawn on this is carry structure. First of all, these Na. These are attached on the edges. 4, 5, 6, 7, and 8, and in the center 9. After that, Cl 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 9 Na and 14 Cl. Now that's not the appropriate value. Let's find out how to just make it clear that how we can identify that on which basis a single structure or a single Na is connected to. Like we don't know that a single Na is connected to how many Cls, so that it makes a crystal structure, and we don't know that how many structures does a Cl make. To understand it, we should first be known that how many Cls are connected with Na and Na connected with Cls. As I told you in the previous lectures, that it is a repeating structure. So let's understand it on the basis of that. Just suppose at the initial, suppose this Na. Now from how many Cls it is connected? First of all, this Cl, this Cl, this Cl, and this Cl. How many Cls? 4. Now that is common sense that there would be, of course, another unit cell connected to it, in which it also have Na at here, 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 and so on. Now that thing to be discussed, that this Cl is not arranged. Like there would be distribution of half NaCl or Cl ions. It will be halved. This ion will be halved. Just because if we will place to same charged negatively, just suppose that this is a Cl ion. If we will place both negatively charged close to each other, so it will repel. So how the bonding can be made? So for that reason, it is naturally separated in the half, like half is of this unit cell and half of this unit cell. So according to this structure, will be known that basically this is structure and this is this one. Let me change the color. This one and this one is halved, but still if we talk about this one and this one, so it is free. So this Na will connect to this particle as well as this particle. So how many particles that is gained? 1, 2, 3, 4, 5, 6. So there are 6 ions. If we talk about it's not of Cl, it's of Na. Like Na is connected with 6 Cls. If we talk about the Cl, just suppose that this Cl, it is connected with how many Nas? 1, 2, and 3. Now, probably if it is attached by, just suppose that this is a phase, then this is a phase, then it is connected to one more. So of course there would be again distribution. It will be connected to this one, then this one, and then of course this one. Now how many ions does it make? 1 at the back, that means 2. 2 from here to 2 from here to. How many? 6. Now you'll be thinking that what I am doing. Let me tell you in detail. Now, if we talk about single Na, so it is basically connected with 6 Cls. Like this is not Na, this is Cl. So it is connected with 6 Nas. As it is, if we have a look on the structure, so a single Na is also connected with same 6 Cl. What is this 6th number? Now this 6th number is coordinate number. That means that we have 6 coordinate numbers. 6 Na is connected with 6 Cls, 6 Cl is connected by 6 Nas. That was the coordinate number. Let's find out that how many chloride ions does we have actually. So, as you all know that a cube had 8 corners, 12 edges, 6 faces, 1 center. So, if we talk about the edges and the faces, so basically it has 12 edges and 6 faces. How we can calculate that how many ions does we have? For that, we gonna divide 8, like we know that there are 8 corners. And we know that in the 8 corners, each Na is 1. Like in the 8 corners, there is 1 Na place. Each corner has 1 Na, so it is divided by 8. And if we multiply that, the answer will be 1. That means there is 1 ion on the corner. If we talk about the face, that is 6. So each face, that means that in one direction we have 2 phases and we have 1 ion on the face. If we divide that, we're gonna have 3 number. Now that means that we have 3 ions on face in one direction or in the direction which can be seen by a single way. Now if we're gonna add these both, so what will be the answer? It will 4. That means the ions are 4. As it is in the second one, the sodium. 12 phase edges. On each edge of one direction, we have 4 edges, and each edge has one ion. So when we're going to divide it, 4 will be the answer. And as we have one Na in the center, so we're going to add it and the answer will be 4. This is how we calculate the ions. Now what is this written? As you know that Na and Cl has ratio of 1:1. That is not true. 1:1 is the simplest form. Actually, it has the ratio of 4:4. And we know that every time a compound is written in the simplest form, that's why it is having 1:1. So what we have learned in this lecture till now, we have learned the coordinate number as well as how there is 1:1 in the NaCl. And that's good. So till next video, thank you.